Hello boys and girls, how are you? I'm going to start a new lecture in physics second paper on the basis of chapter number 5. And name of the chapter is here, electromagnetic induction and alternating current. Electromagnetic induction and alternating current. Boys and girls, my today's topic is here, mean value or an effective value of AC electromotive force. According to my last class, you know very well what is the equation of AC electromotive force. You know that the equation of AC electromotive force, it will equal to E is equal to E naught then sine omega into T. Here E naught is the peak value or maximum value of AC current or AC voltage or AC electromotive force. Omega equal to angular frequency of AC voltage and T is the time. If you draw the graph of AC voltage versus time, then you will get the following graph. So the graph will equal to here, or the graph will be here. So this is the graph of AC voltage or AC electromotive force. In this particular direction here, electromotive force is acting, and also you know that in this particular direction here, time is acting. And the maximum value or peak value of AC electromotive force, it will equal to E naught. It will equal to what? It will equal to E naught is the peak value or maximum value of AC electromotive force. Peak value or maximum value of AC electromotive force. So, boys and girls, I'm going to find out at first what is the mean value or average value of AC electromotive force. In my last class, I will find out the mean value of AC electromotive force for the case of complete cycle. That's why in my today's class, I am to find out AC electromotive force, its average value for the case of half cycle. So, mean value of AC voltage for half cycle. So I'm just considering here the value of half cycle. You know that, boys and girls, the average value of AC electromotive force for the case of half cycle is denoted by E half. It's denoted by E half. It will equal to 1 divided by T time period, but half time period. But here what? Half time period. It is multiplied by 0 to T by 2, then T and then dt. This, then E and dt. E and dt. So this function will give you the mean value or average value of AC electromotive force for half cycle. Now I'm going to put down the value of E. So when I'm going to put down the value of E, then I can say that here 2 divided by T will equal to 0 to T by 2. That E will equal to here E naught sine omega T and then dt. You know that E naught is the peak value or maximum value of AC electromotive force. That's why E naught comes out from the limit of integration. So E naught comes out from the limit of integration, then it will equal to 2 E naught divided by T because it's a constant function. And then integration takes place over sine omega T. Then sine omega T, it is multiplied by dt. It's multiplied by what? Multiplied by dt. Now, boys and girls, when you integrate sine theta d theta, what will be the outcome here? The outcome here will equal to minus cos theta. I repeat, boys and girls, if you integrate sine theta d theta, then what will be the outcome here? The outcome here will equal to minus cos theta. But if this will equal to integration of sine m theta d theta, then what will be the outcome here? The outcome will equal to 1 by m minus 1 by m cos m theta. Okay, so this is the outcome here. But in this particular map, you see that integration of sine omega t dt. So here omega is a constant function. When you integrate sine function, then it will equal to minus cos function. So I'm going to write down here 2 into E naught divided by t. 2 into E naught divided by t. And we integrate this sine omega t dt. It will equal to what? It will equal to minus 1 divided by omega cos omega t having limit 0 to t by 2. At first, you know that omega is angular frequency is also a constant function. It comes out from the limit of integration, and minus sign also comes out from the limit of integration. Then you can write down here 2 E naught divided by minus omega into capital T, and then cos omega t having limit 0 to t by 2. Since here the limiting function will equal to 0 to t by 2. What does it mean? It indicates you that at the place of t, at first you are going to put down the value of upper limit, and then you are going to put down the value of lower limit. I repeat, at first you are going to put down the value of upper limit, and then you are going to put down the value of lower limit. Okay, so upper limit, boys and girls, it will equal to 2 E naught divided by minus omega t. Okay, then cos omega capital T is replaced by here, and then cos 0. What? Then cos 0. Now I'm going to erase the upper part of my board, upper part of this board. So I'm just finding out the value of mean value of electromotive force for the case of half cycle. So half cycle will equal to what? It will equal to 2 E naught divided by minus omega t, and then cos omega into t divided by 2 minus 1 divided by 2 minus 1. You know that omega will equal to what? Omega will equal to here twice pi divided by capital T. So if you multiply omega t, then it will equal to 2 pi. If you multiply omega t, then it will equal to what? It will equal to 2 pi. So the value is here 2 into E naught divided by minus omega t will equal to minus 2 pi. Then cos, in the place of omega t, it will equal to 2 pi divided by 2 minus 1. 2 and 2 will cancel out. It will equal to, for both sides, this 2 and 2 will cancel out. This 2 and 2 will cancel out. So it is minus E naught divided by pi, and cos pi will equal to what? In the bracket here, it is cos pi. You know that. What is the value of cos pi? The value of cos pi will equal to minus 1. Also minus 1 will equal to minus E naught divided by pi multiplied by minus 2. Multiplied by what? Minus 2. So here, it will equal to minus and minus will equal to plus 2 divided by pi into E naught. So 2 divided by pi will equal to what? Will equal to 0.2 by 3.1416. Divided by 3.1416. We'll equal to 0.637. 0.637 of E naught. 0.637 of E naught. That's why I can say that the average value of AC electromotive force for the case of its half cycle, it will equal to 0.637 of E naught. Will also equal to what? If you convert it as a kind of percentage, then you can say that it will equal to 63.7% of E naught. 63.7% of E naught. So this is the mean value of AC electromotive force for the case of half cycle. I repeat, boys and girls, this is the mean value of AC electromotive force for the case of half cycle. Okay, so for the case of half cycle, this will equal to the mean value or average value of AC electromotive force. Now, my next question is, I'm going to find out RMS value of AC electromotive force or effective value of AC electromotive force. I'm going to erase this. So in next segment, I'm going to find out RMS value or effective value. RMS or effective value of AC EMF. RMS value or effective value of AC EMF. Boys and girls, what is RMS stands for? You know that here RMS stands for root mean square value. Here RMS stands for what? Here RMS stands for here root mean square value. Okay, so to find out RMS value of AC electromotive force, we just write down here E RMS. So RMS of E will equal to root mean square value of AC electromotive force. Now, suppose it will equal to equation number 1. It is equation number 1. This is a very complex equation. Boys and girls, root mean square value of AC electromotive force. This is a very complex equation. And to solve this very complex equation, at first I'm going to find out here the mean square value of AC electromotive force. At first I'm going to find out the mean square value of AC electromotive force for the case of a complete cycle. I repeat, boys and girls, for the case of a complete cycle. Now, here E square bar average value of AC electromotive force is square average value. For the case of complete cycle, so it will equal to 1 by capital T integration of 0 to capital T and then E square bar dt. Okay, then square dt. This bar indicates that this function, total function, so E square dt. You know that here E equal to what? Here E equal to E naught sine omega t. Here E equal to what? Here E equal to E naught sine omega t. Since E equal to E naught sine omega t, that's why we can say here 1 by capital T, 1 by capital T at first, okay, and then 0 to T, E square will equal to E naught square, and then sine square omega t dt. Sine square omega t dt. Whole equation I'm going to square the whole equation. Okay, means E naught square here also sine square omega t dt. Now E naught square comes out from the limit of integration. E naught square comes out from the limit of integration divided by capital T. Integration of 0 to t, it will equal to sine square omega t and multiplied by dt. You know that, boys and girls, it's a very complex function here to solve this integration. I repeat, boys and girls, this is a very complex equation here to solve this integration. Okay, it's a very complex equation. And to solve this equation, at first I'm going to use, boys and girls, at first I'm going to use, use here the concept of, I'm going to convert this sin square omega t into cos 2 omega t. How can I convert this? I need to use, I need to have the formula from this. 2 sin square theta will equal to 1 minus cos 2 theta. I'm going to use this trigonometric formula. 2 sin square theta will equal to what? It will equal to here 1 minus cos 2 theta. So to use this formula, at first I need to introduce here the function 2, constant function 2. To introduce here the constant function 2, I need to divide here 2 and multiply here 2. That's why this 2 and this 2 will cancel out. Boys and girls, that's the part. This 2 and this 2 will cancel out. So I'm going to multiply 2 and also divide 2. So 2 and 2 will cancel out. What's the advantage to use this step? My main advantage here, I need to convert this square function into a coefficient based function, that is 1 minus cos 2 omega t. And we can easily handle this equation of integration. Now, it will equal to what? It will equal to here e naught square divided by 2 into capital T. By 2 into capital T. And then integration of 0 to capital T, 2 into sin square omega t. Boys and girls, what does it mean? 2 into sin square omega t will equal to 1 minus cos 2 omega t. 1 minus cos 2 omega t, and it is multiplied by dt. 1 minus cos 2 omega t, and it's multiplied by what? It's multiplied by here dt. Now e naught square by 2 into t. Boys and girls, 2 into t. And here you have to multiply this equation just like this, 0 to 2, then dt minus here 0 to t, then cos 2 omega t, and then what? And then dt. And then what? And then here dt. Cos 2 omega t, and then dt. Now, boys and girls, I need to solve this equation. So e naught square divided by 2 into t, and then it's multiplied by, at first you need to solve integration of dt. Will equal to only capital T. Will give you the value 0 to capital T minus. After integration of cos function, you'll get sine function. After integration of cos function, you'll get what? You'll get here sine function. So integration of cos 2 omega t will equal to 1 by 2 omega sine 2 omega t. 1 by 2 omega here sine 2 omega t. So it will equal to what? It will equal to 1 by 2 omega then sine 2 omega t. Having integration limit, it is 0 to t. Okay. Now, boys and girls, I need to use the upper part of my board. Okay, that's why I'm going to erase this upper part of the board so that I can solve this equation properly. Okay. Now, so I'm just going to find out E square average. Will equal to what? Will equal to here E naught square divided by 2 into capital T. You know that at the place of t, at first you need to use at the place of it is a small t. At the place of small t, you must use the upper limit and the negative sign, and then at the place of t, you must use here the lower limit. So at first upper limit t minus 0. This is the first segment, minus 1 by 2 omega, 1 by 2 omega, and then you are going to use here the lower limit. So if you use the limit function here, it will equal to sine 2 omega into capital T minus sine 0 minus what? Sine 0. So, boys and girls, you know that from a previous part of my lecture, you know that omega into t equal to 2 pi. Omega into capital T equal to what? It will equal to 2 pi. So, I can say here, it is E naught square divided by 2 into capital T. First, from first function it will equal to T. And then here 1 by 2 omega. You know that sine 2 into 2 omega. 2 omega will give you 2 pi. 2 omega will give you what? 2 pi. So it will equal to 2 pi. And then you know that sine 0 will equal to 0. Okay? So here it will equal to E naught square divided by 2 into capital T. Capital T minus 1 by 2 omega. What is the value of sine 4 pi? Do you know this? Sine 4 pi will equal to 0. I repeat, boys and girls. What is the value of here sine 4 pi? You know this. The value of sine 4 pi will equal to what? Will equal to 0. So it is multiplied by sine 4 pi will equal to 0. Okay, minus 0. So total function becomes 0 except this capital T. So it is E naught square divided by 2 into capital T multiplied by T. So here function T and T will cancel out. That's why it will equal to E naught square divided by 2. This is the mean square value of AC current, AC electromotive force. Mean square value of what? AC electromotive force. But boys and girls, I'm going to find out the root mean square value of AC electromotive force. So ERMS function will equal to root mean square value of AC electromotive force. I already know about the value of this mean square value of AC electromotive force, about this function. Indicate the box inside the box function, okay? So it will equal to what? It will equal to here E naught square divided by 2. After this square root over, this function will equal to E naught divided by root over 2. Do you know what is the value of root over 2? I know that, you know very well. Root over 2 will equal to 1.414. Root over 2 will equal to what? It will equal to 1.414. So, since root over 2 will equal to 1.414, then 1 divided by 1.414 will equal to what? It will equal to 0.707 of E naught. In the case of percentage, it will equal to 70.7% of E naught. So these are the equation of AC electromotive force or effective value of AC current. AC electromotive force. You know that effective value is what? The RMS value of AC electromotive force. So the effective value or RMS value of AC electromotive force will equal to the formula is here ERMS will equal to, at first it is E naught by root over 2, then it will equal to 0.707 E naught, then it is 70.7% of E naught. What? It is 70.7% of E naught. So these are the values of AC electromotive force and its effective value. Boys and girls, now I'm going to give summary of AC electromotive force. I'm going to give what? Summary of AC electromotive force. Okay? I'm going to find out its 3 average. Okay? At first, before giving summary, erase this part. So, the summary of my today's lecture. Summary of my today's lecture. Number 1. Mean value or average value of AC electromotive force. Mean value or average value of AC electromotive force. Force is E for half cycle, it will equal to 0.637 of E naught, will equal to 63.7% of E naught. So this is the mean value or average value of AC electromotive force. Now, boys and girls, in next segment, you already know about the effective value or RMS value of AC electromotive force. So, effective value or RMS value of AC electromotive force, AC EMF, electromotive force is ERMS will equal to E naught divided by root over 2, or it will equal to here 0.707 of E naught. It also equal to here 70.7% of E naught. So this is the value of RMS value of AC electromotive force. So this is all about my today's lecture. Boys and girls, it is all about my today's lecture. After this lecture, you can explain this thing very easily, and this formula you can use here in different mathematical formula. They're different to solve different mathematics, different properties of AC current or AC electromotive force. So I'm going to finish my today's lecture. All of you stay at home, stay safe, and keep studying at your home. Thank you very much. Thanks for watching my today's lecture.